Hello everyone, let's talk about Vieta's formula. There is a theorem that if there is a quadratic equation ax squared plus bx plus c is equal to 0, we can express the roots as the r1 plus r2 is equal to negative b over a, and r1, r2 is equal to c over a. And similarly, for a cubic equation, we can also express the sum of the roots as negative b over a. The product of the three roots as negative d over a, and the sum of two of the roots multiplied together is equal to c over a. So there exists a lot of more complicated formulas, but for high school math contests, these two should be enough. Now we can prove these formulas. There are a lot of more complicated ways to prove it, but now we would just like to understand how to use these formulas in the context of a math contest, so we can just derive it using the quadratic formula. So you should remember that for a quadratic formula, the root is equal to negative b plus or minus b squared minus 4ac all divided by 2a. So we can say that the first root, r1, is equal to negative b plus b squared minus 4ac over 2a, while r2 is equal to negative b minus the square root of b squared minus 4ac over 2a. So firstly, we can try to prove the addition of roots. r1 plus r2 will be equal to negative b plus the square root of b squared minus 4ac divided by 2a plus negative b plus b squared. This will be minus b squared, the square root of b squared minus 4ac over 2a. So this would be they have a common denominator, so we can just merge them together. Minus b squared minus 4ac all over 2a. So now we notice something interesting, which is that we have plus b squared minus 4ac square root, and then we have minus the square root of b squared minus 4ac, so they cancel out. So now we have a simplified version, which is just negative 2b over 2a, and then we can also cancel out the 2, so the addition of roots in the quadratic formula will be negative b over a. Similarly, we can find the multiplication of roots using the quadratic formula. So we have negative b plus the square root of b squared minus 4ac over 2a multiplied negative b minus the square root of b squared minus 4ac over 2a. So this may look like a daunting expression, but we can identify that the top expression looks like a squared, which corresponds to the negative b minus b squared, which corresponds to this thing, which is equal to a plus b times a minus b, which is, so we can just use the identity. So over here, a corresponds to negative b, while b corresponds to the green circled thing. So we can just simplify our expression into negative b squared minus b squared minus 4ac squared over 4a squared, which will just be equal to b squared minus b squared minus 4ac over 4a squared, which will be equal to b squared minus b squared plus 4ac over 4a squared. So since we have b squared and b squared, we can just eliminate it. Then we have 4ac over 4a times a, so we can cross it out. So the multiplication of roots will be equal to c over a. Now here we have an example question when we want to find the roots of the quadratic x squared plus 5x minus 5x plus 6 without using factoring or using the quadratic formula. So we can just use the Vieta's formula as we derived above. So the addition of roots r1 plus r2 will be equal to negative b over a. And in this expression for ax squared plus bx plus c, we can see that a will be equal to 1, b will be equal to negative 5, and c is equal to 6. So negative b over a is equal to 5. Similarly, r1 times r2 will be equal to c over a, which will be just equal to 6. So we can just see that with trial and error, 2 times 3 is equal to 6, and 2 plus 3 is equal to 5. So the roots are equal to 2 and 3. Now let's solve some context questions. Let r1, r2, and r3 be the roots of the polynomial x to the power of 3 minus 14x plus 15x minus 16. So we can compute this expression. So it may be tempting to find each of the 3 roots and then add them up. However, we can do a shortcut. So 1 over r1 plus 1 over r2 plus 1 over r3, we can try to multiply them by a common factor so that they can have the same denominator. So it will be r2 r3 plus r1 r3 plus r1 r2 all over r1 times r2 times r3. So after expanding it, we can actually apply the Vieta's formula. So in this expression, a is equal to 1, b is equal to negative 14, c is equal to 15, and d is equal to negative 16. And then using the formula, we can know that r1, r2 times r3 is equal to negative d over a, which is equal to negative of negative 16 over 1, which is 16. So this thing is equal to 16. And then r1, r2 plus r2, r3 plus r1, r3 will be equal to c over a, which is 15 over 1, or equal to 15. So this will be equal to 15. So the value of this will be 15 over 16. Nextly, we can find the sum of the reciprocals of the roots of the following equation. So this is not exactly a quadratic, but we can we can multiply both sides by x to change it into a quadratic. So 0 times x is still equal to 0, but on the left hand side we have 2003 over 204. X squared plus x plus 1 is equal to 0. And the sum of the reciprocals of the root will be 1 over r1 plus 1 over r2, which will be equal to r2 plus r1 over r1 times r2. And we know that R1 times R2 is equal to C over A, which is equal to 1 over 2003 over 2004, which will be equal to 2004 over 2003. And R1 times R2 will be equal to, wait, we already found that. So R1 plus R2 is equal to negative B over A, which will be equal to negative 1 over 2004 over 2003, which is equal to negative 2003 over 2004. Oh, here is a mistake. Okay, 2003 over 2004, negative 2004 over 2003. So we can just plug in these values back. R1 plus R2 is equal to this. So negative 2004 over 2003 all over 2004 over 2003, which is equal to negative 1. So the answer is B. Thank you so much. I hope you enjoyed learning the Vieta's formula. See you next time.